Hi everyone, welcome to section 1.4, which deals with decimals, and we're going to be talking all about decimals, rounding, adding, subtracting, multiplying, dividing, converting to fractions, percents, simplifying square roots, integers, and locating them on the number line. So first of all, what is a decimal? A decimal is basically another way of writing a fraction whose denominators are powers of 10. So let's say, for instance, here we have 0.1, which is 1/10, right? This is the tenths place, the first place. So notice here, tenths place is to the right of the decimal. 2 spaces over is the hundredths place, so that's equivalent to 1/100th. 1, 2, 3 is the thousandths. 1, 2, 3, 4, the fourth is 10,000. So notice that in the denominator, you have 1, 2, 3, 4 decimal places. Here you have 1, 2, 3, 4 zeros. Okay, so to round decimals, we look at, first we have to decide what's the decimal place that we're rounding to. And then we look, in order to decide whether to round up or stay the same, we look to the decimal that's immediately to the right, okay? And then we round depending on if it's greater than or equal to 5. So let's say, for instance, here we have 18.379. So for A, we want to round to the nearest hundredth. What's the hundredths place? The hundredths place, tenths, hundredths place, right? So in order to figure out what to do with this number, we look immediately to the right at 9 here. Okay, so 9 is greater than 5, so we round up. So it's going to be 18.38, and that is rounded to the nearest hundredth place. So the tenths, nearest tenths, 18.379, so starting over, this is the tenths place. Okay, so we look at the number immediately to the right only. Okay, this is greater than 5, so we round up, 18.4. Okay, that's to the tenths. Now the nearest whole number, if we start with the same decimal, the nearest whole number is this one, the ones. So we look at the 3, the one immediately to the right, to tell us whether to go up or down or stay the same. So since 3 is less than 5, we just keep it as is, 18, and everything else goes away. Okay, let's talk about adding and subtracting decimals. So first of all, we have to understand if it's adding or subtracting. We can line these up vertically, and we can use placeholders as zeros if we need to. And then we add or subtract as they were whole numbers, and we just use the decimal place as it goes. So let's go ahead and look at this. We have negative 23.5 minus 41.38. So notice I lined up the decimals. However, so it's the same sign, so we're going to add. Remember that same signs add. So, this is a zero placeholder. So we just add them, and we're going to keep the sign, which is negative. So 8, there's the decimal point, 4, 6, and it's a negative 64.88 for A. For B here, we have 14.65 minus 20. Okay, so we're subtracting these two, but we're going to keep the sign of the larger, which is 20. So it's easier to go from greater to smaller. So we can write this way. Notice I put decimal placeholders for that. Now we're going to subtract the difference, but we're going to keep the negative. Okay, so subtracting 10 minus, we're borrowing, right? 10 minus 5 is 5. This would become 9, okay? 9, and we had to borrow from here. So then that's going to be here. So 10, this is going to be 9 as well. And this will be 1. Okay, so 3. Here we have 5. So 5.35, but then the answer will be negative because the 20 was originally negative. Okay, so for multiplication, we just can go ahead and multiply, writing it vertically, lining up the numbers on the right. So it's a little bit different. So we rewrite them, and we ignore the decimal points temporarily. So 4.075 times 3.9. So we would multiply this. This is negative, but we'll just use that at the end. So then we, at the end, we'll write the what the answer, the product, has to have the same number of decimal places as the sum of the decimal places in the factors. So let me go ahead and first let's multiply. 9 times 5, 5, carry the 4. 7 times 9, 63, plus 7 is, plus 4 is 67, carry the 6. 9 times 0, 0, plus 6 is 6. 9 times 4 is 36, okay? Then we're going to add that to, and we're going to remember you have a magical 0. 3 times 5 is 15, carry the 1. Carry the 1 over here, sorry. 3 times 7 is 21, carry the 2, right? 22. 3 times 0 is 0, plus 2 is 2. 3 times 4 is 12. So now we're going to add all of this up. So we get 5, 12, 9, 8, and 15. But how many decimal places will the answer have? We have 1, 2, 3, 4 decimal places. So 1, 2, 3, 4. So final answer is 15. It's negative 15.8925. Okay. And you can, of course, check with your calculator. Okay, what if you have a decimal, if you're multiplying by a decimal that's a power of 10? That's very easy because it's a fraction. This 10 here, we move the decimal point to the right, the same number of places as the number of zeros in the power of 10. So for A, if you're doing 5.63 times 10, the answer will be 56.3. For B, if you're multiplying 5.63 times 100, that's 2 decimal places, 1, 2, your answer will be 563. If you're multiplying 5.63 times 1,000, we have 1, 2, oh, we need one more, and we include a 0, so that's going to be 5,630. Okay. And dividing, remember we first determine the sign of the quotient, and then we make the divisor a whole number by moving the decimal point all the way to the right, and then we have to do the same thing inside the house or the dividend, okay? So let's say here we're saying this is what goes inside the house, 25.65 divided by, since these are both negative, it's going to end up being positive, right? 0.06. Oh, I wrote that wrong. 0.06, okay? So in order to really divide, we need to move this 2 spaces over. So that means we need to move this 2 spaces over. So the decimal is actually here and comes up here. So now we can think of this as 6 into 2,565. 6 goes into 25 4 times, right? 24. Subtract, bring down the 1, 6, 5. 6 goes into 16 twice. So that's 12 here. Subtract 4, bring down the 5. 6 goes into 45 7 times. That's 42. The remainder is 3, and we can add a 0. So 30, 6 goes into 35 times. So that's your answer right there, 427.5. Okay, what if we want to change a decimal to a proper fraction and a fraction to a decimal? To convert a decimal to a proper fraction, we determine what place value is the last digit, and then we write the fraction. So here we have 3. This is the tenths place, hundreds place, thousandths place. So for A, that's 374 thousandths, okay? And then we can simplify if we want. But then for B, in order to write this fraction as a decimal, we know it's going to be negative. So we're basically taking 5 and we're dividing it by 8. Okay, so since there's something there, we put a decimal. 8 goes into 50 6 times, right? Subtract, that comes 2, bring down a 0. 8 goes into 20 2 times, that's 16. Take the difference, that's 4, bring down a 0. 8 goes into 45 times. So that's it. So it's negative 0.625 because the original was negative. Okay. All right. Convert a decimal to, percent to decimal and vice versa. To go from percent to decimal, we have to move 2 places to the left. Move to left. And to go from decimal to percent, we move 2 places to the right and then add the percent sign. Okay, so let's go ahead and do a couple of examples of this. Let's say we have 62%. We want to change this to a decimal, 1, 2 this way. That's going to be 0.62. 135%. That's going to be 1, 2 to the left. So that's 1.35. We remove the percentage after we've changed it. 13.7% becomes 0.137 or 137 thousandths. Okay, so now let's go from decimal to percent. If you have 0.51, we go 2 spaces to the right. So this is 51%. Okay. If you have 1.25, changing it to a percent, move 2 spaces to the right, 125%. And then finally 0.093, we move 2 spaces to the right. That's equivalent to 9.3%. Okay. A few more words. Let's talk about squaring. So a square is if you have a number raised to the power 2, multiply it by itself, the answer will be considered a square, okay, of, the first one. So let's say here you have 2 squared is equal to 4. So then 4 is the square of 2, right? And if we go backwards, if 2 squared is equal to 4, we would say that 2 is the square root of 4, okay? So another way to think about it is the square root of 4 is equal to 2. All right, so then let's go ahead and continue. So let's talk about a little bit about the square root. This is also known as the radical. This inside is called the radicand. Okay, so if you have a number that's a square of another, then the square root of that takes you back to the original. Okay, so the square root of 25 is the positive number whose square is 25. So square root of 25 would be 5 because 5 squared equals 25. Okay, square root of 121 would be 11 because 11 squared is equal to 121. Okay, and then negative square root of 144, that would just be negative 12. Okay, all right, let's continue with a little bit of, this section has a lot of stuff in it. We're going to talk about classification of numbers. So remember, counting numbers are the ones that you can count on your hands and so on, right? Beginning with 1. Whole numbers are the counting numbers and 0. Okay. Remember, you can research this on your own, but the invention of 0 is very interesting. And then finally, the integers are all the negative whole numbers, right? Negative numbers, 0, and the positive whole numbers. Okay. Now, a rational number is basically any number that can be expressed as a fraction. Now, where you have integers in the fractions. Now, every possible whole number or integer can be rewritten as a fraction and is considered rational because you can take a whole number and then write it over 1. Right. So let's see here. Anything that's irrational is any number that can't be written as a fraction. Okay, so something like this, an example of a rational number is it does not stop and it does not repeat. So pi continues forever, 3.14, right? 159 continues, it never ends. And so if you have a good way to figure out if something is rational or irrational, if the decimal form repeats or stops, then it's a rational because you can express that as a fraction. And if it doesn't repeat or does not stop, then the number is considered a rational. So let me show you this really cool chart. The real numbers system, right? All the numbers that we are studying in this course, for now, is the set that contains both the rationals and the irrationals. Remember that the rational numbers include integers, which include whole numbers, which include counting numbers. Now, some examples of irrational numbers, we have pi, we have the square root of any prime. Okay, so let's go ahead and classify some numbers here. So we have these numbers, -7, 14 over 5, 8, square root of 5, 5.9, and -64, square root of 64. So A, the whole numbers, right, are those that are positive. So the only thing here would be 8. B, the integers would be -7. This is a 7, by the way. 8. And then square root of 64 is 8. So that would be -8, which is negative square root of 64. Okay. And what else? Then you have C, the rationals. So rational numbers, again, -7, 14 over 5, 8. Remember, because all whole numbers and integers are considered rationals. 5.9 because it stops. Negative square root of 64, which is equal to -8. And that's that. And then D, irrationals, you have the square root of 5. And that's it for irrationals. And then E, real numbers are all of them. Okay. All right, let's see here. We now want to include fractions and decimals on the number line. Let's start with fractions and locate them on the number line. So you see 1/5 is closer to 0, right? It's 1 out of 5, right? -4/5 is closer to -1. Okay, 3 is obviously it's on 3. You have 7/4, which is a little bit greater than 4/4. So it's 3/4, right, of the way between 1 and 2. -9/2, that's equivalent to -4.5. So over here, -5 is on the -5, and then 8/3 is equivalent to 2 2/3. Okay. So let's do, let's locate 0.4 and -0.74. So 0.4 would be right about here, less than 1/2, right? And then -0.74 should be close to -1. But like right where 3/4 is, about here maybe. So -0.74, okay? And that's it for this section. Good luck. Here's your super fun homework. Happy studying. And again, email me if you have any questions, and I will see you on the next video.